we are going to look at translations on graphs. Anytime you have to graph a line, you can use a t-table, but this video is focusing on the translations. Before we move on, we are going to talk about the parent graphs. The parent graphs, like x equals y, that is for every x, we have a y, the same y, so at x is 1, y is 1, x is 2, y is 2. So this is the general parent graph, and this line can move up or down, can have different slope, it can move at any time, depending on what values you put with x, whether you add or multiply. The other parent graphs, y equals absolute value of x. This will be in the form of a v. So any x you choose, it will be the positive y. So positive absolute value of positive 1 is 1. Absolute value of negative 5 is positive 5. So it will be in a v. Absolute value will be v. Y equals x squared. This will be in the shape of a u. Y square root, or no, yes, y equals square root x. This will be like the parabola on its side, but we're only concerned about the positive y's. Because otherwise, if we say square root of x is positive and negative y, we would have another leg down here, but then that would not be a function. A function is only 1 to 1, 1x to 1y, not 1x to 2y's. So that's why we focus in on the square root of the positive value, or the principal square root. Y equals x to the third, which would be like I don't know, a groovy line. I don't know what you call that, but 1 to the third power is 1, 2 to the third power is 8, so that's why it climbs a bit higher. And then negatives, we go down to the negatives. The cubed root of x would be similar to the x to the third. These are inverses, except it's going to be laying on its side. The funky S curve, if you would, the funky S curve, but to the side. These are also inverse functions where you have to cap this off at the domain, or the range has to be from 0 up above, and the domain from 1 to or from 0 to infinity. Okay, so these are the 6 parent graphs. We will actually look more with these 5, and we are going to use translations. Okay, so those are the parent graphs. Remember their shapes. And when we translate, we are just going to do sketches of the graph, not necessarily graphing the points right on. If you want to graph the points right on, I mean, you can be that picky. You can also use a t-table to do so. So the first thing we're going to look at are vertical shifts. Vertical shifts. So the constant is outside the parent graph. This will, if we have a negative number, we move down. down that number, down that many units. If it's positive number, we move up that many number of units. So for instance, y equals x squared minus 3. This is how I want you to show me your graph when you are just sketching it. So the first thing you need to do is sketch in or dot in your parent graph. So the parent graph of this is a U. We are going to go down 3. This is a minus 3. It's outside of the parent graph. So the negative 3 is not affected by the squared. So we are going to take this 0, 0, and all of these points, so the 1, 1, 2, 4, so on and so forth, all points are going to move down. But we can go ahead and move the origin down here. And then all these other points, so that's another way you can be accurate, is if you accurately punch in your parent graph, then you can take every single one of those points and move them down. Move them down 3. And then go ahead and fill in your graph. So the dotted one is your parent graph, and the actual graph that we are wanting to graph is the solid one. And that's all there is to it. Y equals absolute value of x plus 2. Again, the constant is outside of the parent graph. The parent, oops, I just messed up. The parent graph gets dotted in. So 1, 1, 2, 2, 3, 3, 3, you know, all the dots. If you want to, you can accurately put those in. We're going to move the graph up 2, so every single dot will be moved up 2. I just focus in on the center. It will move up 2, and I didn't move it up 2, 1, 2, it's right here. I'm making all sorts of mistakes. And you're going, and if you have other dots, you're going to move those up 2 units as well, and draw in your graph. Right now, what I'm doing is just sketching them, and that is okay to do. Even if you have graph paper, you can still sketch them in. Let's look at horizontal shifts. The constant, and I just misspelled that. The constant is inside the parent graph. And if it's a negative number, you're going to move right number of units. If it's positive, you're going to move left. And the reason being is if you solve for x, if you take that value and solve for x, then you can see, oh, well, if it was x minus 3 squared, well, x equals 3. So you are actually going to go positive 3 when in reality it was a negative 3 in there. So this one, when you do horizontal shifts from left to right, you have to remember the opposite of what you want to, where you want to go. So a negative number, although the negative numbers are on the left side of the graph, you still have to move right. If you have like x plus 2 and you solve for x, x would equal negative 2. If you just take x plus 2 equals 0, well, then that would mean that you have to move left 2 because the x, what x equals is negative 2. So whereas if you just look at the constant, it is positive. So again, this is why you have to do the opposite. So for instance, square root of x minus 4. The square root is a swoop, or 0, 0, 1, 1, 4, 2, 9, 3 for those if you want to accurately put in your points. The constant is inside the parent graph, meaning that the parent graph, or the squared, absolute value, square root, cubed, whatever may be, the number is affected by that. So we have to move right 4, and there is our new graph. And again, every single point does move along with it too. Okay, y equals x plus 5 to the third. So our parent graph is x to the third. So that would mean that 0, 0, 1, 1, 2, 8, negative 1, 1, negative 2, 8, negative 8. This is inside, so we move over 1, 2, 3, 4, 5, and all the other points move that way, but sketching the graph will be fine. And we're done. So that's horizontal, that's horizontal and vertical shifts. And then we have what we call a reflection. Of graphs. So if there's a negative in front of the parent graph, we reflect across the x-axis. And when you move these values, sometimes it's not the x-axis, but you flip it on the line of where your apex is or your vertex is. So for instance, y equals negative x squared. Okay, it's different than this, okay? That is not the same. We are taking the opposite of x squared. So whatever value we have here, we're going to take the opposite of it. So the parent graph is in the shape of a U. If we're reflecting it, it's going to actually reflect down. So your x or your y values will be negative. So at 1, 1 will be at 1, negative 1. At 2, 4 will be at 2, negative 4. So the y values will be negated. Sorry, I cannot think of that word. It would be negated in this case. It's different when you actually have to move the graph. So let's go ahead and do some combination translations. So here is the parent graph. It's a V. And what we're going to do is we have to move the graph up 2 and right 4. So this dot goes here, and then all the other dots go with it. But what we're actually going to do, since it is negative, we are going to reflect it. Okay, so this dot here, here's our line right here. So if we had a dot here, it would be equidistance from here down to this line. Okay, so that one's a little trickier. We can't just negate the y, because this might be a 4, a positive 4 where it moved down to a 2 or whatnot, a 3 and a 1, let's say. There we go. This is this dot is at y equals 3. Then our dot would have to move down to y equals 1. So sketching the graph is fine, but I want to keep in mind this apex, however many units the next dot is up, it has to be the same units going opposite of that that horizontal line. Shrinking and stretching. Okay, so this is when there is a coefficient, or we call that a scalar, in front of the parent graph. If scalar is a fraction, and the fraction is in between 0 and 1, the graph shrinks vertically. Okay, so you've taken the y-axis and you're taking the y-axis and you're squishing it down. You're squishing it down like this, so it gets wider. If scalar is greater than 1, then, oh, not x, let's go a. If the scalar is greater than 1, then the graph stretches vertically, which would be the y-axis. So you take the y-axis and you're stretching it so it gets skinnier or taller. This one gets wider. Okay, now let's go ahead and practice that. Y equals 1/2 x squared. Okay, so our parent graph lies there. Since this is 1/2, this is going to shrink. Everything's going to get flatter or wider. So then we're going to actually have a wider U. And we're done. Now, if you were to do this by the points, then you would take the y value. So at 1, 1, we would be at 1 and then 1/2. At 2, we would be at 2, 4. Well, you would have to take 4 and cut it in half, which that would give us 2, 2. So you were actually taking, on our parent graph, what we're doing is taking our y's and cutting them in half. Y equals 3x squared. Our parent graph, and what we're doing is taking all of our y's and multiplying by 3. So we're actually stretching the graph and it's going to get longer. So at 1, we're at 1, so that would be now 1, 3, and so on and so forth. So one more example, and let's see here. One more example. And this will be in the term of a U. So this is the parent graph. And then we are going to move this graph up 4. And I don't mean to put a dot there, but we're going to move it up 4, and then we are going to move it right 2. So here is our new dot from our origin. We don't have to reflect it or anything, but we do have a 1/3. So remember, a 1/3, it's going to give us a wider U because we're cutting all of our y's into thirds. So that is our graph. It's not very good, but try your best, as long as if you're sketching this, and you can sketch it on graph paper, you can sketch it on graph paper, but make sure you're widening or shrinking or stretching your graph and make it noticeable. This one kind of looks okay. It kind of makes it look like the parent graph. But anyway, Hopefully this video will help you understand vertical shifts, horizontal shifts, reflections, and stretching and shrinking. And then this was a little bit of everything besides the reflection. So if this had a negative out in front, we would just take this and flip it completely around this point. We'd flip it down. Anyway, that's all I have for this. See you next video.